So we've talked about the basics. We've actually discussed what all these statistical measures mean. Let's actually put them to work here. So here's an example of a list of 20 students' SAT reading scores that I just made up completely randomly. And they're stated here. And I want to do some things with this. I want to find the mean, median, and mode. I want to find the range, the minimum, and the quartiles, and then I want to test for outliers. Well, we can do this by hand. It's time consuming though. So let's do as much of this on our calculator as we can. So let's actually go through with the calculator how to actually do this. So because I'm dealing with something statistical, my best bet is to go to the stat key. So I'm going to press the stat key and open up that menu. And I want to edit my information, edit my list of data, so I'm going to press edit. And I would go through and enter in all of my data into one column, and you can see that I've already done it just to try to save some time, and I've got all 20 values here. So if you want to pause the video and catch up and enter it in, you can absolutely do that, but I'm going to move on for now. I've got all my data entered. I'm going to go back to the stat key, and because I'm trying to calculate some information, I'm going to go to the calc menu. And I'm going to use the one var stats option here, one variable stats. Press enter. I'm going to check my list. I put my information into L1, so I'm just going to change that by going to second and then L1. So you make sure that my list says L1. We didn't use any frequencies in our table. If you were to take a statistics course, you would actually explore this option, but we don't have to worry about it for now, so we can leave it blank. And I'm going to go to calculate. And it pulls up all of the information I need to know, right? You can see my mean right here. We'll talk about this guy a little bit later. That's standard deviation. We talk about the number of values in our data set. That's n. And here's my minimum, my quartiles, my maximum, and that's all my information. So it gives us almost all of the information that we need. For now, we don't need to worry about these three. But all of the information we need is right here, much faster than if I tried to actually do this out by hand, cross out for every number, add every number together. It's all right there. So I know I said it's all right there, but it's not all right there. The calculator gave us a lot of information, but there's still a little bit of work that we need to do on our own. The first one is the mode, right? It doesn't tell us the most frequent piece of data, so we need to go back into the chart ourselves, into the data ourselves. And it seems like 750 is the one that appears the most, right? I see 4 times. I don't see anything else that appears 4 times, so our mode is 750. There's only one mode. So if you remember from the last video, we call this a unimodal set of data. The other thing we don't get from our calculator is the range, but we have the pieces that we need to do it, right? We remember that range is the minimum value, sorry, the maximum value versus the minimum value. That would be a little more logical. Max minus min. So our maximum value we can tell is 800, and our minimum value is 580. So that gives us a range of 220. Obviously, the higher the range, the more spread out the data is. The last thing we would look at is the IQR. And are there any outliers? So let's find the IQR. So the IQR is quartile 3 minus quartile 1. So that's 750 minus 692. So that's an IQR of 58. And our test, if you remember, our test for outliers, for outliers, is to look at these two values here, kind of see where my boundaries would be. So let's figure out what those are going to look like. Quartile 1 minus 1.5 times the IQR. And that's going to give me, let's see, 692 minus 1.5 times 58, and that's going to give me 605. So anything less than 605 is going to be an outlier. The other thing I want to look at would be Q3 plus 1.5 times the EIQR. So 750 plus 1.5 times 58 plus 1.5 times 58, 837. So ultimately, here's my test. I want any numbers less than 605 or any numbers greater than 837 are outliers. Do I have any of those? Well, let's see. Nothing's greater than 837, but I do have something less than 605, and that's 580. So I actually do have an outlier. 580 is an outlier, and this is the thing that's influencing the mean. So I would want to acknowledge that when I'm doing my calculations, and that's why I have you look at this kind of thing. So this is all great. The numbers are great, but our brains don't always do well comprehending numbers. Our brains like visual. So let's talk about some visuals. The first one would be a histogram, and a histogram looks a lot like a bar graph. But it's not exactly a bar graph because we're dealing with numerical information here. So a histogram graphs frequencies. Graphs the frequency of values over certain intervals. The great thing about a histogram is it makes it really easy to spot the mode, you'll see why in a second, and what we call the skewness of the data set. So the skewness just means, is there a lot of high or low values, right? Higher or lower values. So we're actually going to follow these steps as we work with our data. So we want to define equally sized intervals that are appropriate for the data set. We should have about 5 to 7. So if we go back up to our data set here, and actually maybe I can copy and paste it so I don't have to keep doing this. Cool. So here's our data. Let's see, we need 5 to 7 intervals, so counting by hundreds is not going to be enough. Maybe we can count by 50s. So we want an interval, and we want its frequency. So let's count all the things from, well, we need to cover 580 somehow. So maybe we'll start by 550 to up to, but not including 600. So 550 to 599, and there's one of those. And then we would go 600, and we want to stop right before 650. And I don't see any of those, right? And then we would go 650, not quite to 700. I see 1, 2, 3, 4, 5, 6. You can see this is a little bit tedious. 700, we're going to kind of just follow this pattern, right? 1, 2, 3, 4, 5. And 750 to, well, 799. 1, 2, 3, 4, 5, 6. For the sake of being consistent, right? 2 in that 800 range. And we could really be picky if we wanted to and shift it over just one unit to catch these boundaries, but we don't have to. So here's all my data. And now we're done with our data, so I can get rid of this to save myself some room. Here's my frequencies. We've done the first step. We've done the second step, count the number as values that fit into our intervals. This is called the frequency. Now we're just going to graph frequency with the intervals, and our bars should touch. So even though we're going to start the graph at 0, I'm going to break the graph and start it at 550 just to fit all my information on the page. 600, 650, 700, 750, 800, 850. And then I need to make sure I've got at least 6 bars here. So 1, 3, 4, 5, 6, 7. Cool. I like to label the first couple just so I know what I'm counting by. Now all we're going to do is graph it. So I have one that goes from 550 to 599, so up to 600. So 1 here. And normally we would fill that in also. I don't have anything from 600 to 649, so that's going to stay right there. I've got 6 from 550 to 699. So 3, 4, 5, 6. So right about here. I like to draw the horizontal part first and then draw the lines down. I just think it's easier. And again, I would shade this in. I've got 5 from 700 to 749, so there's my 5. And like I said, the bars should touch, and that's because these are continuous pieces of data. 750 to 799 is also 6, roughly. And then 800 to 849, there are 2. So I'm going to find where 2 is. Just like that. And that's our histogram. So it doesn't give us the exact mode, but it gives us what we would call a modal class, where like we can say that most of the data falls in either the 650 to 699 or the 750 to 799 range, and that number is going to change based on how you set your intervals. So it gives us an estimate of the mode, and it also, if there's a lot of like 800s or a lot of like 500s, we would be able to see that really clearly as well, which is helpful. So that's our histogram. The next one we're going to look at is a box and whisker plot, or just a box plot. And what's great about this is it's going to illustrate the minimum and the quartiles. And this helps us give a sense of the spread. If there are outliers, we're going to show them as dots. And I'll show you, fortunately, our data set does have an outlier. So I can show you this bottom point, which is super important. If there are outliers, the whisker, you'll see in a second, is placed at the next non-outlier. And I'll show you what that means. So let's put our data back up here. And let's bring these numbers back because these are going to be important. Copy. Let's bring these back. I'm going to do this on a number line. This all goes on a number line. So let's start just by drawing that out. And we'll do 500, 550, 600, 650, 700, 750, 800. Look at that, it fits perfectly. I didn't even plan that. Again, I like to mark some of my tick marks just so I know what I'm dealing with. Our box plot is going to show 5 numbers. It's actually going to show these 5 numbers. So let's show those 5 numbers. So I like to start with Q1, Q2, and Q3. That's going to make our box. So Q1 at 692 is going to be, I don't know, about here. The median at 745 is going to be about here. And Q3 at 750 is going to be right about there. Again, it doesn't have to be perfect, but it should be pretty close. And this is going to make our box, so we're just going to connect the box. Okay. Now we want to make our whiskers, and normally they would just be our minimum and maximum. So for the time being, I will show them like that. So there's our whisker, and here is our other whisker at about 580. And draw that a little bit better. There we go. So normally, if it was not an outlier, we would show them as just normal whiskers. But we do have an outlier. So let's get rid of this whisker here because we know that this is actually an outlier. We're going to show that as a dot instead. Which means we show the whisker. We still should have 2 whiskers at the next non-outlier. So if 580 is an outlier, the next available data point I have is 650, and 650 is not an outlier, which means I can place my whisker at 650. So this gives us a really good measure of where most of the data falls and how close the data is for the most part, except for this outlier that's kind of sticking out on its own. Some people like to label it. I do find it helpful, so if you have the room, it can be helpful to just do a quick labeling. It's not going to hurt. And that would be our box plot. This would be our box plot. So it's a nice quick visual to show just how spread out the data is.